Hello and welcome back to our mini-series on understanding and mitigating the risk of internet-connected industrial systems. My name is Joel Angel. I'm the founder of the Industrial Control Systems Cybersecurity Institute and also the founder of the popular website SCADAhacker.com. I joined Phoenix Contact today as we celebrate National Cybersecurity Awareness Month, where we're going through an actual real case study of a response effort that I performed after identifying a particular control system was inadvertently connected to the internet. So let's pick up where we left off. In the first episode, we talked about the scenario and the data collection activity. Then we came back in episode 2 and analyzed that data to get an idea of where the actors could reside in the world and some level of capability and intent. Now we're going to actually start to use threat intelligence to determine exactly from all of the 3,100 initial actors, which was reduced down to those that actually connected sessions with the devices, to finally those that performed actions or had indicators that showed that they were not necessarily friendly actors. So now what we're going to do is we're going to use another open source product called SCADA. SCADA is an advanced intrusion detection and intrusion prevention infrastructure. It's kind of the evolution of the very popular Snort product. And what it does is it allows you to import into it a range of threat intelligent feeds through a variety of plugins that are written using a common scripting language so that these plugins can be used across many different intrusion monitoring packages. So in an offline manner, I took that data that was collected at the site and then ran it through SCADA against a current threat feed that I put in right before I finished the data collection exercise, and then had it plot these actors on a global map. So in the previous episode, we kind of saw where actors were based on just simple geolocation. This now narrows that field down to those actors that cause some trigger within the threat intelligence feeds. So let's take a look at what we did here. So using SCADA, I focused in on a plugin set that contains both lists of known compromised IP addresses. So sites that either host malware or are known to generate active malicious traffic, as well as those sites that are scored against a reputation factor. And they maintain this reputation, it's updated multiple times a day, so that as people start to see different IP addresses come and go based on their actions, there's a reputation score. And these sites are then put into a series of plugins that can be used to map a particular IP address to a different threat group. So in this particular case, it's very interesting right out of the gate, is that on the far right, we see the aggregate of 3 main groups of triggers when we did this analysis. Now the ones in green are the only authorized IP addresses. They consist of myself and the client. And remember, I said there was an exercise overseas. As you can see, this took place in England. And there were the multiple IP addresses that were used by the service provider that was overseeing the operation of this remote site. But right sandwiched in the middle of there is Russia, and a large, very large number of attempts from IP addresses that are attributed to various parts of Russia. So now, remember the global map, we're very concerned because, as we all know, the level of sophistication of foreign actors is growing at an exponential rate. And anything like this is reason to be alarmed. So what happened from here? So what we did was we took all that data and we wanted to group it to show the threat feeds that cause these alarms to be triggered. And again, as you can see, the very top list is in what's called a block list, the D-Shield block list. And this is what the security advisors and threat feed generated data suggests everyone blocks at their perimeter. There should be no reason why this group of IP addresses is let through. Now the other ones are those reputation groups, but again you can see right out of the bat our top 3 categories that accounted for a large percentage of those hits was actually from sites that should have never been allowed through a security perimeter. Of course, remember, we did not have any security appliances outside that Seymour panel. So what could they do? A lot. So let's take a look at a little bit more data. So when we start to parse it down by those 3 common groups on the previous slide, you see that in the first, roughly 50% of those IP addresses were originating in Russia. On the second reputation score, all 100% were actually Russian IPs, as was the same with the third reputation group. So we have a little bit of concern here. Now, I've always been challenged, do you really think the attack was taking place from Russia? That's not for us to decide. I'm here to point attribution and say, hey, these sites are probably questionable. We need to secure our infrastructure from these type of sites, irrespective of where they reside in the world. So, we're going to pick this up again once we now have our threats identified, we know where they're at, we now have to take a look at what we can do to this small package system that was supplied by this OEM with no security, great functionality from an operational point of view, but very little security in terms of cyber resilience and protection. So, in the final episode, we're going to take a look at how we solve this problem. Thank you. Look forward to seeing you soon.